Good morning, this is Dr. Turner for Integrated Math 3. Today we're going to be looking at 4.2, adding and subtracting rational functions. Go ahead and just jump right into it. Before we do get started though, I want to emphasize that a lot of what we're doing now at this point relies on either information that we've already learned, it could be from the previous sections that we've covered in this class, or it could be things from Math 2. So if you need a little bit of time to go back and review some of those topics, you're more than welcome to. All the videos are available. What we're going to look at right now, adding and subtracting rational functions, also is going to tie back into simplifying rational functions, which is basically dividing from Unit 3. So just keep that in mind. If something's going a little too fast, you're more than welcome to reach out to me and ask for additional help, or like I said, we can always go and look at those videos. So we'll go ahead and pull this up for 4.2. There it goes. Okay. So there are a couple questions on this assignment that just simply ask you to simplify the rational function if you can. So when you add and subtract these, if you can simplify, you want to. So for instance, let's say I have something like x squared minus 16 over x plus 4. So there are a couple questions that are stepping back for just a second and saying, hey, how do you simplify a rational function? This is a rational function. Remember that we are simplifying these by factoring. So the numerator, because it's a difference of squares, I can rewrite that as x minus 4 times x plus 4. And once I do that, I have an x plus 4 on the top and bottom that I can cancel. And so I'm left with my answer, which is x minus 4. It doesn't have to be a perfect square. It could be something else that could be factored out. For instance, negative x minus 3 over x squared plus 7x plus 12. So because the denominator is a quadratic function and because the a term is 1, that would lead me to believe that it's probably going to be factorable. The numbers that multiply to get 12 but add up to 7 are 4 and 3. So this is x plus 4 times x plus 3. In the top, I have negative x minus 3. Now this is a common thing that will happen when you're factoring where it almost looks like something can be canceled out, but I have a negative x and a negative 3 in the top and a positive x and a positive 3 in the denominator. So what you can do is you can factor out that negative sign, and by doing so, now you have something that's the same on the top and bottom. That cancels out and leaves you with your answer of negative 1 over x plus 4. So that is all to say, if you can simplify once you're done adding or subtracting, then you want to do that. Now let's get to the actual topic, adding and subtracting. The first ones are maybe the easiest, where we have examples where we have the denominator that is the same. Let's say 3 over x and 1 over x. Just like any other fraction, if my denominators are the same, then I'm able to simply add the numerators and keep the denominator. So 3 over x plus 1 over x would be 4 over x. And that is because the denominators, the bottoms, were the same. It doesn't matter how simple or complex those denominators are. As long as they're the same, all you have to do is add or subtract the numerators. So let's say I have x squared minus 1 in the denominator, and over here I have 2x over x squared minus 1. Okay? Because the denominators are the same, I keep the denominator and subtract the numerators, 4x minus 2x. You do want to combine like terms. You do want to be careful with your signs. Right? Paying attention to if it's addition or subtraction. So let's say I had x over x squared minus 9 minus negative 3 over x squared minus 9. The two negatives in the top would become a positive, so that's x plus 3 over x squared minus 9. And like I mentioned, you want to be careful. If you can simplify, you need to do that. In this particular one, I can. The denominator is a difference of squares. So this ends up being x plus 3 times x minus 3. I have an x plus 3 that can cancel out. And be careful, if you cancel something out in the top, that doesn't mean there's nothing there. There's always an invisible 1. So this is 1 over x minus 3. So for most students, those aren't too bad. We'll do one more, these types. X squared plus 4x plus 3. And the top, I'm going to put 2x minus 6. And on the second fraction, we'll do addition. 4x plus 1 over x squared plus 4x plus 3. So combine like terms, 2x and 6x. Negative 6 and positive 1. And then in my denominator, because it's the same, I keep it. So hopefully they're pretty straightforward. Like I said, if the denominator is the same, add or subtract the numerators respectively. When you don't have the same denominator, that changes. And if you recall from just basic fractional operation, let's say I had something like 1/3 minus 1/4. You have two options here. One is that you can change it to have the same denominator by first figuring out what is the least common multiple. Your multiples of 3 are 3, 6, 9, 12. Multiples of 4, 4, 8, 12, 16, so on and so forth. First number they have is 12 in common. So I would multiply the left fraction by 4, top and bottom. We have to keep it balanced. And then I would multiply the right fraction by 3, top and bottom. Once you do that, then you have an example where the denominators are the same. And so you simply subtract the numerators to get 1 over 12. You can do this also by doing the butterfly method. So 5 over 4 minus 2/3. You do 5 times 3 minus 4 times 2 over 4 times 3. 15 minus 8 gives you 7 over 12. Either of those methods are acceptable. Sometimes it's easier to do one rather than the other. So let's take a look. Let's say I have 4 over x squared minus 2 over x, for instance. Now, here, because I know that the only factors of x squared, for instance, are x times x or 1 times x squared, what you can do is just change one of these fractions so that they have the same denominator. So on the right, if I multiply that by x, that makes it x squared. And of course, I would have to multiply the top by x as well. That gives me 4 over x squared minus 2x over x squared. And now that the denominators are the same, I can write that as a single fraction. 4 minus 2x over x squared. Most students are okay with that. But then it gets kind of tricky where you have, some type of polynomial as your operation in the denominator. So let's say I have x plus 1 over here, x plus 5 over here, and we'll keep it to addition for right now. So in these examples, what's the least common multiple? Well, this is where doing the butterfly method might be a little bit easier, but essentially what you're doing is that you need to change it so that the denominators are the same by multiplying by the other denominator. So again, I would do this as butterfly method, but you can do it the other way. I'm going to show butterfly method first. You're going to do 4 times x plus 5 plus 3 times x plus 1. And then it's over x plus 1 times x plus 5. Of course, you don't want to leave it like that. You're going to distribute your 4. You're going to distribute your 3. And then you're going to do FOIL, or the box method, in the denominator. That is x squared plus 6x plus 5. Okay. Now the numerator I'm going to clean up. 4x plus 3x is 7x. 20 plus 3 is 23. And that is considered my simplified answer. So that's one way of doing it. That's how I personally would do it. You don't have to do it that way. The other way you could do it is essentially anything that you don't have in your denominator, looking at all the denominators. If there's an element that you don't have in your first term, so looking at specifically, let's step back here for a second. If I'm looking at, let's say, 4 over x plus 1, I'm looking at all of the denominators, and I don't have an x plus 5. So I would need to multiply that first fraction by x plus 5 on top and bottom. So remember, as long as you do something to both sides, or of the fraction, then you're good. Then I look at 3 over x plus 5. Well, that doesn't have an x plus 1. So I multiply top and bottom by x plus 1. Now I have the same denominator. Yes, this one's 1, 5. This is 5, 1. But remember, the commutative property says multiplication is the same backwards and forwards. So then you could write it as a single fraction. So you'd be back down here. And you would continue to simplify until you got to 7x plus 23 over x squared plus 6x plus 5. Look at another example like that. Let's say we have 3x over x squared minus 5 over x plus 1. Same idea. I'm going to do butterfly method, so 3x times x plus 1 minus 5 times x squared, and that's all over x squared times x plus 1. You'll then distribute your 3x to get 3x squared plus 3x, and that's minus 5x squared. In the denominator, I'll distribute the x squared to get x cubed plus x squared. And then in the top, because I have like terms, 3 minus 5, I get negative 2x squared plus 3x, and that is over x cubed plus x squared. Anytime you have just x's, kind of tells you that you probably can simplify again. So what I can do is I can factor out an x on the top and bottom, like so. And by doing that, I can cancel out an x, leaving my final answer of negative 2x plus 3 over x squared plus x. And that is considered simplified. In all of these examples, we're looking at scenarios where I have two rational functions that I'm combining, but the same would be true if I was looking at an example where I have more than two. To keep it simple, you only have a couple of these on your assignment, but let's say we had 3, for instance. So let's do 4 over x minus 2x over x plus 3 plus 5 over x plus 3, for instance. Okay. So here, we can't really do butterfly method, so we have to revert back to that other way where I am looking for what I'm missing in my denominator. So for number 10, I have an x, but not an x plus 3. So I would be multiplying by x plus 3 on top and bottom. And that is minus the second term. I have 2x over x plus 3. I don't have an x in the denominator, so I'm going to do x plus 3 times x. And in the last term, I am missing also an x, so I'm going to multiply top and bottom by x. Once I do that, I need to clean it up. So the denominator I've already done, right? X times x plus 3. So I know that I'm going to be able to combine these. And then in the top, I have 4 times x plus 3 minus 2x times x, which is 2x squared, and then plus 5 times x. Distribute the 4 to get 4x plus 12 minus 2x squared plus 5x over. Go ahead and distribute the x squared plus 3x. And then last, I'm going to combine like terms, 4x plus 5x, and I will put this in order. Negative 2x squared plus 9x plus 12 over x squared plus 3x. As long as you have all the terms with the correct signs, I'm fine with that. However, to have the most correct answer, you want to be going in order of degrees. So notice how the numerator I rearranged. I started with x squared, then the x, and then the constant term. There are more examples that we can see and do here, but that's 10. That feels like a good number to stop at. Hopefully that was enough. As always, if you guys need more help, please reach out to me during office hours. Otherwise, have a good day, and I will talk to you soon. Bye.